Hello everybody and welcome to this first video in this brand new YouTube channel. So I am making this YouTube channel to document many interesting and advanced topics on programming. As you might know, I've been developing uh, an extension or an npm package to serve HTML live with hot reload, and it's considerably faster than alternative like live server. Uh, but if you come from my Twitter or X, you might know that. But a problem I'm facing is that I'm currently using the Node.js file watcher, that is FS Watcher. So now it's been working well until now, and nobody reported any issues. But before I was using a Node.js package called Chokidar. So I don't know if you're familiar with it, but it's very popular and it's the most popular file watching package for Node.js. But this package has one issue, that's it has memory leakage issues, since it doesn't handle unwatching or unlinking and linking files. So my solution was to revert back to Node.js and use it by using its default file watcher system, which fixed the memory leaking problem, and nobody reported any issues since then. But I want this to be optimized because Node.js doesn't have an optimized file watcher. So I want this to be optimized and I want it to be fast. And that's the reason I'm writing this code to watch files in Rust. Now, Rust is a very popular and the most loved programming language actually, and it's because of a good reason. It's very fast. It's lightning fast Rust. So what I've done is I've decided to use Rust for the next version of the package, which I'll link actually below. I'm gonna give you the link to the both npm registry and GitHub. It's open source. Feel free to use it, change it around however you want. But today we're going to be building a file watcher with Rust, and we're going to be using the Notify file watcher extension, crate, as it's known in Rust. So as you can see, I've already created a folder using cargo new, and it's just a basic folder, nothing about it. If you just if we say like for example cargo run, then it will say hello world. And it's quite faster because I've already run it to just test it and it works. Now I've made one difference, that is if we open our cargo.toml file, you can see that here I have under dependencies I have notify version 6.1.1. This is the latest stable version currently as the documentation has put it, and we're going to be using notify version 6.1.1. So let's start actually. So let's just open from the source folder our main.rs file, and you can see here is the basic uh, templates that Rust provides us. And now let's continue. First thing we want to do is we want to create a channel. Let's say uh, txrx from channel. So what is this? Actually, for this to work, we need to import it from the standard library of Rust from sync mpsc. Then we need to import channel. So what is this channel? A channel is like, if you're familiar with web development, there's a concept called WebSockets where we keep a connection alive between two addresses, two ports between the client and server, and information is transferred in real time between those. The channel is basically the same thing. We open a connection between a TX or a transmitter and an RX or a receiver, and information will flow consistently and without being stopped until the program ends or they are out of scope, that is, between the TX or the transmission channel and the receiving channel. And we're just destructuring this because it provides a tuple here. Uh, so that's basically it. So now we're going to be using these channels so that we can actually transmit messages when a file changes. So let's continue. Let's create a mutable reference, immutable integer called watcher from the recommended watcher. This is actually coming from the notify create, by the way. So let's create a new instance of it, and we're going to pass it tx, say config default, then dot unwrap. Okay, so now we need to import this stuff from the notify create. So just say notify from the notify create. We're gonna import a couple of things. First, we're gonna import the config, and we're gonna speak about that in a bit. Second, the recommended watcher and search watcher. Now, for this to work, we need to import those three. What are they? Okay, let's go word by word. Recommended watcher. Okay, a recommended watcher is, uh, you know that operating systems like Windows, Linux, macOS, they have their own APIs. So these APIs have their own ways of handling file system watching. And Notify is basically using APIs of the respective operating systems. So when we say recommended watcher, we don't have to configure anything for the current operating system of the user. We can just say recommended watcher and it will automatically detect the operating system and it will work for the best using the best API for that operating system. We create a new instance of it and we just pass it tx, meaning any stream, any data coming from this recommended watcher will come and enter to TX or the transmission channel. Then we're saying config default. This config default is a default configuration object that is kindly provided us by the notify create itself. So it's just a default configuration. And as you know, unwrap because this might return an error, but it's unlikely. So that's why we're actually doing this. When it's unlikely, it's okay to use unwrap. But if it's an error where it could really happen or it has a big chance, I don't recommend using unwrap or just use a match or something and uh, use proper error handling. But here we can use unwrap because an error is very unlikely. Finally, we have imported the watcher because Rust actually doesn't always show us where we use our imports. The watcher is being used by the recommended watcher here. It's being used as actually let's get it to it. We can say watcher the watch, and here's where we're using that. So the washer is just for this. Actually, so let's say water the wash and path the new. Now we're telling it the program what paths to watch. So we're saying the root path, and the root path is not the source path. It's actually the path or where you created your folder, your project. So it's actually the project file. For me, it's fs watcher. I think rs, right? That's the path. So. Uh, Recursive, we're gonna pass this to it. Then, as usual, we say unwrap. So it's gonna be watching this path. If we come here, it's gonna be watching this Rust fs watcher. This is the root path. So we're just saying watcher dot watch the path, uh, and we're just saying path dot new, and so that means we have to import the paths uh, from the standard library. Just say path. So now we have the path and we're creating a new instance of that path in the roots directory. And we're saying recursive mode, recursive. And we need to import that too here. So what is recursive mode? So simply, if we recursive means how much depth should the file watcher be. For example, if you say non-recursive, then it will watch only this portion here, the home path or the root path. It will only watch that path. But if you say recursive, it will also watch subdirectories. So its depth will increase. Um, what's next? So after we do that, now we have a watcher. But if we run, uh, for example, if we say come here and say cargo run, it will build and it give us because we spelled the default wrong. It's there's a T here. So let's try that again. Let's just clear and cargo run. Okay, so it's finishing without any errors. And the reason it's finishing is because we are watching the file system, but we are not doing anything with the stream information that's coming in. So we need a for loop to watch the information and to consistently do something with that information. So let's say for response in Rx. So then what we can say is simply uh, we can match the response. Okay, so the response could be either an error or it could be a success. So we gotta for if it's an error, we pass it an e and just print it using the print line macro. Print line, and we just say error e, and we use the Rust templating system, and we finish. So if it's an error, we just print it to the console. But if it's not, if it's okay, uh, we're not gonna do anything with the result right now. We just what we want here is to get notified when a file changes. We don't need what the file was changed to, the content, what kind. We just need if a file has changed, we want to do something. So so just say handle change, and we're gonna be creating this function. Uh, so let's just come here and say uh, let's create a function called handle change, and simply it will print line change. So it's just going to print line change. Okay, so when something changes it will print line change. Simple. Okay, so one thing here, this is not a semicolon, it's a comma. um, Now let's try it. If everything works fine now, we should be able, if we clear and say cargo run, and it should, yeah, it should compile, then it should not shut down, because it should be listening. Because here we said for response in Rx, here's where we're using the received channel. Sorry. So now if we make changes to this file, uh, there should be an output on in the terminal that says change. So let's just comment. Let's just say change. Let's write change here. Let's just save it, and if we see it here, it says change, 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 change. Now it is working perfectly, but you can see that for one change we are creating these many responses. So that's not what we want, because for as for my use case, which is to make a file watching system, to make a call to the browser to refresh it in my actual in my project. If for one change there is being 6 or 7 events sent, then the browser will be overwhelmed and it will probably crash, right? So we don't want that. And why is it happening like that? Okay, it's because if you want to make an IDE or text editor in the future, you have to know that each IDE, for if you're using VS Code, NVim, Vim, Any IDE uses its own process to create uh, or to change, modify files. It will do some stuff like create a copy of that file, edit that, and save it to the real copy, then delete that. That's what Vim is basically doing. So so actually Notify is working perfectly because it's listening to all those changes and not only the one. So what we want is we want to debounce it. What is debouncing? Debouncing is basically uh, avoiding or removing noise. Noise is something from the main process that we don't want. So a side effect. So here the side effect is multiple uh, responses, right? So we only want one. And how would we debounce it? Is very easy. What we're going to do is we're going to wait a certain amount of time, very little. I'm choosing to do 250 microseconds. We're gonna be waiting 250 microseconds until all the results are in. Then we're gonna be combining them into one result and just pushing that result into uh, the transmission. Okay, so it's very simple actually. We're just gonna be first. Let's create a debounce time. Um Debounce time from the duration from millis, that is milliseconds, 250 milliseconds. So we're gonna create a 250 millisecond time. And we're gonna be calling it the bounce time. For this to work, actually, we need to from the time standard library. Just we gotta import the duration, right? We gotta import the duration uh, here. Then we have this to bounce time. Next, we want a mutable variable called last event time, and this will take care of when was the last event called. So only after 250 milliseconds will the rest of the events be valid. So uh, we're making it mutable because it will change, right? So once you make another change, the last event time will change to the current one. For now, let's just say instance out now. Now, for if we want to do this, again, we have to import the instance from the standard library of time. Just say instance. So then we have to pass this into the handle channel function, right? Since we do want it to be uh, any change, including noise debouncing, we want it to be handled in the handle change function. So let's just pass it these two. The first thing is we're gonna pass it debounce time, and the second thing is a mutable reference to the last event time. We're doing this because we want to be changing the last event time and the handle change. So of course, if we do that, we have to properly write this in the handle change function as parameters. So just say last event time. Now actually let's start by the bounce time, and it will be a type of duration, and last event time, it's going to be a mutable reference of an instant. So this is basic Rust file or data types. Um, okay, so now we have everything ready. What we want to do is very simple. We just want to come here and say let now equals instant done now. Okay, so we're gonna be creating every time this function runs or every time a change occurs. This handle function will have this new variable called now, which is the moment the function starts running or the moment change occurred. And we want to say if now the duration since. Okay, so from the start of the function, we want to wait 250 milliseconds to collect all the information or the responses, and then we want to pass it. So what we're doing is basically from saying now, and from now duration since, and we say last event time. This is a pointer, if you're probably familiar with it, and say if it's greater than the bounce time. Okay, here. So if the duration since the last event time, okay, so if the current when the function is running, if it has been the debounce time, or if it has been 250 milliseconds since the last event, you see, if if it has been 250 milliseconds since the last event has been registered, then we just want to say print line change. And finally, this works. This should work now perfectly. And the only thing we need to do is just use a pointer to say last event time and change that last event time to now, uh, because we want it to be reset, because in the next run we don't want it to be considering the previous handle change time, but we want it to use a new time. So now if we save this, and if we come here and say, you can see it's been working. It's been saying change as we were writing. And let's stop and clear. Let's say cargo run, and let's see if there's any errors. No errors. Okay. So now what we can do is simply let's let's just come here and uh, at the top of our file, I'm gonna create a comment and say hello. And now there should be one change. Hello. See? There's only one change. And if I say, comma, how are you? And if I go here, there should only be one change. So it's perfect. It's working perfectly. So this is how you create a file watcher using Rust and uh, notify crates. I am actually creating this video because I found it to be very difficult to find a good documentation on the notify crate. They are very outdated, and I had to search from very posts, forums, and to find a valid implementation. So I really do hope that you could learn something from this. You can implement it in your project. Uh, I hope you have understood Rust at least in some capacity more than you did before watching this video. So again, another change. So thanks for watching. I will be creating more videos in the future on advanced real-world implementations. So if that's something you are interested in, please subscribe. Thank you very much. I'm going to leave the link to the live server uh, npm package below. So check it out if you're into front-end development. Yeah, thanks for watching, and I'll see you in the next video.